All right, good morning, everybody. Welcome to lecture today. I feel like from Friday to Wednesday is such a long time, and I haven't seen you guys in so long. It's good to be back with you. If you didn't know what that song was, that was thanks to a request from one of your classmates. So happy to take a request there. But anyway, we're going to resume our discussion with Chapter 6 today. I really apologize about I don't know what, hopefully the recording is working right now. I think it should be. Sorry about that on Friday. Were you guys able to access the PowerPoint slides with the annotations? Maybe. Well, again, there was no recording posted from Friday. I had a little error on my end, but I did filled in the lecture slides, like what's up here on the screen. So that should have, I don't know. That's at least an attempt to cover for myself there. Apologize about that. I hope you guys got the email. Homework is not due this week. It's the next assignment will be due next week. And just a heads up that the first exam is coming up not on Tuesday, but the next Tuesday. It's October 1st. So personally, I can't believe it's already almost October. I guess it's not really. I've got a couple weeks left, but that's on the horizon, and you guys should be taking some time in recitation to go over some review things. So just a heads up for that. Any questions before we jump into material today? Other than why would I subject you to that crazy song at 7:55 in the morning? That is a good question, isn't it? Okay, well, just remind you what we did on Friday. We finished up things with regression in Chapter 5 and kind of jumped into Chapter 6. And I wanted to just kind of go back through some things from the beginning of this chapter's notes, remind you what we did. It's a while ago. So remember that in Chapters 4 and 5, we were looking at relationships between two variables. We did that using a scatter plot, correlation, then we did regression lines. But that was, again, two quantitative variables. And now in Chapter 6, we're going to look at relationships between two categorical variables. So our general notation here is we're going to have, for the individuals that we're interested in collecting information on, maybe that's you guys, I'm going to place you into a generic number R categories for the first variable, so maybe what class rank you're in, something like that. And then I'm going to put the same people, the same individuals into another group of categories, a second variable, maybe what state you're from, something like that. So for our example here that we're going to look at a lot here, remember that we have our first categorical variable was political party affiliation, and our second categorical variable was do you support an attack on Syria, yes, no. And that's kind of so the first categorical variable, we have R would equal 3. We have 3 different possibilities for that variable. Second categorical variable, the support for the attack, we have 2 categories, so C would equal 2. And that gives us a total of 6 possible outcomes, so 6 possible categories that you could be placed in if I want to cross-classify you by each of these variables. So for each of my political parties, I have yes or no, you do support, or you do not support the attack. So this is all things that we looked at on Friday. The way we'll display these 2 categorical variables is called a two-way table. Kind of helps us to organize these things. We also call them contingency tables. And then here's our example. Here's the actual data that we have from our example. So this is from a website. You can check that out. That was retrieved a week or so ago. But so again, you can see from this table, kind of this is a way to organize the data that we have. So this is a modified poll. Here on this column on the side, we have our first variable, which is our political party identification. Along the top, we have our other variable, and then this section in here, we list the actual numbers of people that we have gotten in there. So this is all review, but just kind of a reminder that this is the way we're going to display data when we have 2 categorical variables we're working with. And we chatted about this briefly, again, based on your knowledge of this debate, so kind of ignoring anything that we're doing in this class. Would you expect there to be a relationship or an association? And we decided, yeah, of course, there's certainly a relationship between your political party identification and whether or not you would support the attack. There's probably some relationship in there that we could deduce. And so, again, pushing that discussion of, we'll learn how to answer that question more formally later in this class. But for now, just kind of thinking that's the kind of question that we want to be able to answer from this type of data. All right, so again, this is still reviewing here. The final thing we talked about on Friday was this thing called marginal distributions. So again, the first thing that we want to do when we're looking at this two-way table in which we're looking at two categorical variables is to look at each one separately. So we have each of these two variables, and we can examine each one of these things separately. And so we call these marginal distributions for each of our individual variables because they appear at the right margin and the bottom margin of the table. And then a more formal definition here was that of what this thing is. And then this is something that I don't think is in your notes, but just when you're asked to create a marginal distribution, or if you want to know what that is, the important two things to include is, first of all, what are the categories? What are my possible groups that I have of this variable? And then what are the number of people that I have in each group? So that's all I mean by what a marginal distribution is. So I just want to list what categories, what groups I have of that variable, and the number of people that I have in each group. Yeah.
Should we include the total if we do that?
Yeah, so should you include the total? Yes. Yes, that's probably good practice. And 3, the total. And maybe one other modification is that for the second one you could put or the percents. Either one of those is just fine. So either the number of individuals you have in each group or the percentage of the total that you have in each group. Same thing is fine. So again, example of what I mean by this, we can make our marginal distributions for the two categorical variables we have in this first example. The first variable here, this is variable, I guess I might have had this listed as variable 2. I'm going to list if I want to give the marginal distributions, again I want to give what my groups are, and then the percentages. So here are the groups up here. So do you yes, support, and the other group is no and do not support. And yes, then we have a space for our total down here. And again, we had our counts or percents down here. So let's see, we had 79 or 79 out of 190, which was 41.6%. The people who do not support, we had the rest of them 111. Or we can write down the percentage as well, and that was 58.4%. And then the total we had was 190, or of course 100% there. So again, this is a marginal distribution here, because note that I've listed which groups I have of this variable, what my two categories are, and then the counts and percentages. Similarly, for my other variable, I can list, I can give my marginal distribution for the party identification. And I've already written in the categories, so here are my categories or groups. And then over here I can fill in the counts and the percentages here. So I have 60, which is 31.6%. 40 people were independents, which is 21.1%. And then the rest of those guys are the Republicans, the 90, and that's 47.3%. So that's, again, when we're looking at two variables, as we're doing here, we're trying to Remember, the ultimate goal is thinking about relationships between these two categorical variables. First thing to do is look at each one of them separately, see what that might tell us about these variables, and then we can move on to looking at thinking about them together. So, any questions you guys can think of about marginal distributions or two-way tables? Kind of what the data is, what we're looking at here. All good. So, quick question for you, maybe. What would be one way of displaying a marginal distribution here? Anybody have any ideas? You could do a bar graph. Absolutely, yes. A bar graph would be a great way to do it. Who else has another idea? That's exactly right. Yeah.
Pie chart.
Pie chart. Absolutely right. So if you think back to chapter 1. Again, this is a categorical variable, so how do we display categorical variables? Things like a pie chart or a bar graph. Exactly right. So not going to take the time to make that now, but just keep that in mind that you could use either of those things to display this information that we have written up here right now. Very good. Okay, so again, marginal distributions, we're looking at things separately. The two-way table allows us to look at the interaction between these variables. So a first type of question that we might be interested in is this thinking about the interactions between these variables is an AND question. So this is a first type of question that we'll look at. And we'll just kind of jump in here. What if the question that I want to know is what percentage of the respondents are Republicans who support an attack on Syria? Which you can kind of imagine that there's an and squeezed in there. So you could also read that question as what percentage of the respondents are Republicans and support an attack on Syria? So who can help me out with this one? Start out with the fraction is fine. We can write down the percentage then. I think I heard it. Choice B. You said 32 out of 190 is our. And why did you say that one?
Because there are 32 Republicans in this.
Okay, yes, exactly right. So you're right. So the response was we want to go with 32 out of 190 because we have 32 Republicans who support the strike. So very good. So again, when we're looking at, if we want to know what number of people are in both of those categories, we can pick out the support column and the Republican row and just figure out how many people fall into that cell. And then again, we're interested in what percentage of everybody in this thing. So indeed, choice B is correct. So again, when you have a question with an and in there, you're kind of zooming in on just one particular cell in the table, and you just want to kind of, just as you guys, your intuition told you there, just kind of pick out that one cell. Okay, so we have and questions, and we can also have the other type of question here. Another type of question is called an or question, and that's when we want to include people from more than one group. So a question that I might now ask is what percentage of the respondents are Republicans or supporters of an attack on Syria? So I'll give you a quick minute to maybe think about what that one might be. Does anybody have an idea? Anybody from the back section there? Yes, sir.
C.
Choice C. Why do you say choice C?
I added up the 2 Republicans, 3258,
Mm-hmm.
and then I added all the supporters together. I don't know if I did that right or wrong.
Okay. So what you said, I think, is that you added all the Republicans together. So you took these two numbers, And then you added all the people who support the, okay, so that would be, so did you add, yes, so I'm guessing you just added those other two numbers on there. Exactly right. So that, I think choice C is indeed correct. But so choice C is correct. Nicely done. So again, there's maybe two ways of doing this. The first way is just to kind of add up all the individual cells that correspond to the people that we're interested in. So so what we have is 31 plus 16 plus 32 plus 58. Divide that by 190. We have everybody in here, and that is indeed 137 divided by 190. Did anybody choose a different strategy or get to 137 in a different way? Yeah.
Instead of like adding up all the numbers in the cells, I just took the total for Republicans and then added 79 minus 32, since I'd already counted 32 ones.
Okay, very nice. Yeah. So the response was that instead of adding up all the individual cells, which works great here, but what if you have 10 categories maybe? We can just pick out, switch colors here. You picked out the total number of Republicans that we had, and then you added in the total number of people who support the strike, but noting that we've then counted these 32 people twice. So we want to subtract those off. So another way of doing this question would be to take 90 plus 79 minus 32. And again, out of 190. And that is equally good. So do you guys see what I did there? I'm subtracting those 32 people off because the 32 people contribute to both the 90 and the 79. So again, both of those ways are equally good of getting to this answer. Any question you guys can think of? Does this make sense what's going on here? You're quiet today. So yeah, so either of those is a fine way to do it, but I would sort of steer you more towards the second second way we did that. In the case that there are many more categories for one or both of your variables, it can be kind of tedious to add up a bunch of numbers when the totals have been given to you there. So maybe had I given you more categories, you would have all gone that way. But again, either one is the same correctness. All right. So we have our AND questions where we look at sort of two groups together. We look at, or where two groups of one category and another category from each of our variables, or they both happen. And then we can look at an OR question here where it's one or the other. And this is a good general strategy of how to figure out what the answer to these questions are. All right, our third and final question here. This is getting more difficult as we progress here. Is called a conditional question. And so, example of this question: what percentage of independents oppose attacking Syria? So I'll let you think about that one for a second. All right, so this one's a little more challenging. I'm going to do a show of hands here. How many of you guys want to go with choice A? It's 24 out of 190. Anybody? Maybe one or two? How about choice B? It's 24 out of 40. So a lot more hands there. How many want to go with C? It's 137 out of 190. Nobody for that one. Or D, how about 24 out of 111? Nobody's taking that one. All right, so the majority choice was choice B, I believe. And I'm glad no one went with C. That one you can kind of immediately scratch off there, right? Okay, so let's think about this one a little bit. So the question is saying what percentage of independents oppose attacking Syria? So who is our sort of larger group of interest that we're looking at in this question, or what is the total number of people in this group that we're interested in? Yes. Okay, right. So the response, we want to look at independents only. So we're saying what percentage of independents oppose attacking Syria? So that's what percentage of independents tells you that we want to look at only people who are independent. So you can kind of think about zooming in here on this part of the table and ignoring all the other information. And so since that's the group that we're looking at here, we can put that number in our denominator. So there's 40 total independents in this table. And then the people who oppose attacking Syria, the only other choice for the numerator there is obviously 24. So again, we're taking the people who oppose the attack who are just independents. And so again, majority rules there. Choice B. Choice B is the correct one. Very nicely done, you guys. All right, similar question. What percentage of opponents of an attack on Syria are independents? So I think we have the same choices up there. How many people want to go with choice A, 24 out of 190? A hand or two. How about choice B, 24 out of 40? Well, of course not. That was the answer to the previous one, right? How about choice C, 137 out of 190? Or what about D, 24 out of 111? All right, so most people are going with that one. Who can tell me why D is indeed the correct answer there? Yeah.
Even as the phrase percentage of opponents becomes the new base number.
Exactly right. Yeah. So the question here says what percentage of opponents. So exactly what you said. That's exactly right. Opponents is the new number that goes in the base or the denominator of our fraction. So again, you can kind of think of, since we're looking at just a percentage of opponents of the attack, again, kind of zoom in on this part of the table and ignore everything else. So now we're just looking at these 111 people who are in opposition to the attack, and then we can pick out the independents, which again is the same number in there. Anybody have questions on these conditional questions, or you don't believe me, or have an argument? Well, then let's maybe quickly discuss the difference between these two conditional percentages. Again, these questions kind of sound similar, right? We have what percentage of independents oppose attacking Syria, and what percentage of opponents are independents. And so again, we have the same number in our numerator, right? There's 24 people who are both independents and oppose the attack. So this is the important number here. So then what's the difference between these two percentages? Maybe a duh question. What's different about our answers to those two previous questions? Yeah. Exactly right. So the difference here is what's in the denominator. So thinking about what number goes in our denominator, or another way of saying that is sort of what group of people are we interested in? Kind of the question to ask yourself. So in the first conditional question, we were interested in just the independents. So that's why we had 40 people in our denominator. Second question, we were interested in just those people who opposed the attack, and so we had 111 in our denominator, and then same numerator. So just maybe okay. So let me give you a quick definition here. Let me fill this in, and then I'll say a little bit more about what I mean by this. So when we change the percent of what, so kind of thinking about what group are we talking about? So when that goes from the percentage of all respondents to the percentage of respondents who are just independents, or the percentage of respondents who are opposing the strike, that's what we're doing there is we're conditioning on one of the variables. So we're sort of another way of thinking about that is if we assume that we're only looking at independents, how many of those people are in opposition, or if we're only looking at people who are in opposition to the attack, how many of those people are independents. So what I mean by that is we're conditioning on one group. We're conditioning on one thing being true. So we're assuming that you're either an independent in that first question or you're in opposition to the attack. And so this leads us to the idea of a conditional distribution. And again, the definition here is it gives the distribution of values of a certain category. Again, among only individuals who have a given value of that category. So let's take an let's actually do one of these, write out what one of these conditional distributions is. So maybe now these include the same components as the marginal distributions we made earlier. So a conditional distribution will have the same basic setup as when we were making marginal distributions. But again, come from that previous slide, the difference now is that we're picking only one sort of subcategory of the table to look at. So the conditional distribution of opponents of an attack on Syria, again, I only want to pick out the part of the table that is the opponents of the attack. So kind of like we did over here, you can kind of just imagine we're zooming in on just the part of the table that has the opponents and sort of ignoring everything else. So that this box here is the information that we want to represent for our conditional distribution. So the Democrats that we have in this category, there are 29, or you could also give the percentage, either one's fine. That's 26.1%. The independents, we've already had that one filled in, and the Republicans, or the rest of them, they're 58 out of 111, or 52.3%. And then we have 111 total people in this category. Some nice lawn care going on out there, don't we? I won't try to compete. Okay, so this is what I mean by a conditional distribution. Again, I'm taking whatever sort of this one category of one of my variables is. So again, my larger variable is, do you support an attack on Syria, yes or no? And then I'm going to take just the people who said no to that question and look at what the distribution of their political identification is. So what's something that you could take away from this conditional distribution here? What's an observation you could make from this here? Yeah.
Majority of the opponents of the attack on Syria are Republicans.
That's right. Yeah. So what was just said is the majority of the opponents of the attack are Republicans. We have the biggest percentages right here. So. So again, the majority of opponents that we have for the attack on Syria are indeed Republicans. Yeah.
Can we say that because Republicans have the largest sampling size? Would that skew the data?
Great question. So the question was, can we say that really because there were the most? If you look back at the original table, Republicans did have the most people that were polled. So is that going to somehow skew the data? Absolutely. That's a perfect observation. So we should say the majority of an opponents of an attack on Syria in this survey. So we can say that because we have, again, whether or not this survey is good or bad, these are the numbers that we got. But yes, to try to expand this to a larger group of people, that would maybe be dangerous to do. So very good observation. So because we have the most, because there are of the three parties, we have the most Republicans in this survey. That should maybe that might throw our numbers off here a little bit. So what would maybe be a better way to, keeping that question in mind, what would be a better way to what would be a better way to answer to make a statement like this? Does anyone have any ideas? If I'm worried that I have too many of one group in here, what could I do about that? Okay, so we could sort of, going back to square one, we could find the same number of people from each party, right? So we could take, I don't know, 70, 80, whatever people from each party, and then we'd have a more accurate number here. Absolutely. That's what you would do on the front end. But what happens if you have already collected the data and you just took 190 people and 90 of them happen to be Republicans? Is there anything you could do to more accurately compare sort of the percentage of the groups that we have that support this thing? Yeah.
You just take the number that oppose out of each group out of like the total number, just get the person that
Yeah. Okay. So that's a great response. So what we could do is we could take the total number of people who support or oppose out of the totals, right? So we could take 58 divided by 90, 24 divided by 40, 29 divided by 60, and we could compare those numbers. That might give us a better idea of percentage of each group that support this attack. Excellent response. So that's not a question that's in your notes. That's just kind of addressing what would you do to more thoroughly answer that question. Very good. Okay, so again, just a hint for answering these questions. We've sort of already hit on this. But the way that I like to think about it is when you have any of these questions that we've looked at, kind of the way to answer them is to think about what we're reducing our world to, or sort of who is our group of interest that we're talking about, and then whatever that group is, that number goes in the denominator. So it's oftentimes not difficult to figure out what number goes in the numerator, but figuring out what group goes in the denominator can indeed be pretty tricky. So the thing to look for is the question will say, and they won't all be phrased exactly like this, but the question will say what percentage of, or what's the total number of, and whatever immediately follows that of statement is the group that you're interested in. So this first question, the one we looked at, what percentage of the respondents and then we have our blah, blah, blah. So again, so that means that the total number of people that, or the group that we're interested in here is everybody who responded to this survey. So our fraction is going to have a 190 in the denominator. And then we went around and we figured out what the numerator should be, and that was, I think, 32. Similarly, that next question said, what percentage of the respondents? So again, picking out the respondents is kind of our, think about that as being our group of interest. That's everybody we have. So again, we had 190 in the denominator, and then we did some work to figure out what number goes in the numerator, and that's an equal challenge, but that was 137. And then again, the last two questions are where it gets tricky. So again, what percentage of independents? So again, our fraction is going to have a 40 in the denominator. And similarly, the last one, what percentage of opponents of an attack on Syria? So we can kind of zoom in on that group of people, and that one had 111 total people. So when you're reading a question like this, the first thing to think about is, who am I talking about? What part of the table am I zooming in on? Kind of what is the sort of the subgroup that I'm looking at? And then you can kind of use your intuition to figure out what goes in the numerator. That's kind of just reasoning it out, just like you guys did earlier. Any question you guys can think of on these types of problems or what I'm talking about here? We all good here? All right. So again, kind of going back to our initial question when we thought about, is there an association between political party and support for this attack? And we kind of said, without really looking at it, the information that we have, we thought that yes, there might be. So again, we're not going to formally answer this question yet. That's coming in chapters 10 and 12. But again, the question that we might think of is, which party is more likely to support an attack on Syria, Republicans or Democrats? And again, we kind of already answered this question, I guess, based on thinking about the number of people that we had in here. But again, the Democrats, we had 31 out of, is that number right? 31 out of 60 support the attack. And Republicans, remember that we had 32 out of 90. I think that's right. So this is about 50%, and this is about, I don't know, 30%. That's very rough average there, but so again, which party is more likely to support an attack on Syria based on this information that we have here? Well, what do you guys think? And everybody said Democrats, right? Yeah, because the percentage of Democrats in this table anyway who support the war are more likely, because we have a higher percentage of those rather, even though, you know, if you were just looking at the counts, 31 and 32, we have the same number of people, but again, we want to use a percentage to answer this question. And again, this is just sort of a fabricated example, but this is the kind of thing that you could do to answer this question, more than just picking out the numbers. So again, we'll have a better way to answer this question later in the course, but this is kind of the thing that we're moving towards anyway. Keep that in mind. So I knew that I would be done with our notes a little early here, so I have a couple examples to go through, and I think we'll still probably get out of here a little early. Hope you guys maybe have an extra sheet of paper. I wanted to give you a little jump start on working through some examples for these types of questions. Or I guess maybe before I do that, any final questions you guys have on Chapter 6? Anything in the notes here? Back channel is very quiet today. All right. Well, let's jump in. So what I have here is, this is out of your textbook. This is number number 19. And by the way, I guess just in general, I'm sure you guys are well aware of this, but if you have a copy of the textbook, all the odd questions have answers in the back. So if you want some extra practice, that's kind of like a standard math textbook thing, is that the answer to the odd questions are all in the back of the book. So anyway, the example here that we have is we're looking at weightlifting injuries. I'm not going to read this whole thing, but we took a sample of about 4,000 patients between ages of 8 and 30, and looked at what type of injuries they had. So again, our two categorical variables here are as age. This is variable 1. And then the form of the, maybe we can say this is the type of accident or type of injury. This is our second categorical variable. So for each of these people that we have in our study, we have them cross-classified by what age group they fall into, and also what type of injury they had. So again, maybe just a quick quiz. Why am I using age as a categorical variable here? Those are numbers, right? Why am I having this a categorical variable? Yes, exactly right. So we're looking at a range of numbers, right? So this is really age groups. Age groups. So just as a reality check there. Okay, so the and again this information is all in your textbook. The question then asks you. Here's what the question says: compare the distributions of ages for accidental and non-accidental injuries. Use percentages and draw a bar graph, which we might forego for now. What do we conclude? So what type of a distribution do I want to look at here? Do I want to look at a marginal distribution or a conditional distribution? I'll give you that much. It's one of the two. If I want to compare the distribution of ages for accidental and non-accidental injuries, do I want to make a marginal distribution or a conditional distribution? And why? What if I scratch out this for 1 second? So suppose the question just says compare the distributions of ages for accidental injuries. Do I want to do a conditional distribution or a marginal distribution? Conditional, right? Yeah. So I want to take, for people who have accidental injuries, I want to look at what the distribution is of those for those ages. So what I want is conditional distributions. And so first, for my accidental, I have my age groups here. This is 8 to 13. 14 to 18, 19 to 22, and 23 to 30. And for each one of these people, so again, if I'm looking at this, I just want to kind of zoom in on the accidental part of the table and kind of ignore the other part. So what's the first thing I need to do in making my conditional distribution here? Add them all up, right? So figure out how many people I have in this group. So we want to figure out what my total is down here. And I don't have a calculator. Who can help me out? 1552? So this is 1,552. Very good. So then I can write down 295 out of 1552. 655 out of 239 out of 1552, and 363 out of 1552. And it would probably be helpful to actually write out what those percentages are. Can anybody help me out there? What about the first one? 19%. Someone want to do the last two while we're working here? 42%.
Last one's
23%. 15%. Very good. So that's my conditional distribution for those people who have accidental injuries. Now we can kind of go back and think about, we do also want to know something about this other group. So my non-accidental injuries. Again, I need to know the total people in this column. Anybody have a calculator they can punch that in? Anybody else? 2559. And then we're going to do the same thing. So we can take 105 divided by 2559. 916 out of 2559. And percentages, anybody?
Last one's 39%.
39%. What else? Someone else? Oh, I thought I had.
So it's like the last one is
21%.
The second one is 36%.
Very good. Thank you guys for the help there. The rest of you guys are off the hook. Okay, so here now I have a conditional distribution for the accidental injuries, and I have a distribution for the non-accidental injuries. And I could draw a bar graph, but I'm not going to. So now again, now we can kind of see a little bit more for each category what our percentages are. So what can you guys conclude anything from these two marginal distributions? And you'd be able to see it better if I had a bar graph. So I apologize for not doing that. Any conclusions you guys can think of here? You have your hand raised, or are you stretching? Yeah, okay. 14 to 18-year-olds are getting hurt the most. Okay, that is true. If we looked at maybe some totals, what the total was over here, right? That would maybe be the biggest number of people that I had in this table. So that's very good. But what about for each type of injury? What type of a comparison could you make? Yeah.
Under 18, there's more accidental injuries versus non, and then as you get older, you get less accidental, more non-accidental injuries.
Exactly right. So if we kind of look at this group right here, so we can see that the younger folks in this group, more of them are having accidental injuries than non-accidental injuries. And then as you get older, it sort of goes in the opposite way, right? So the older groups, more people are having these non-accidental injuries, and less are having the accidental injuries. So that's it. So let's jot that down quick. The 8 to 13-year-olds have more accidental injuries the 23 to 30 have more non-accidental. So that's not the only thing that you could say, and you could be more thorough there for sure. But again, that's the type of thing that we want to answer here is which you can't necessarily see just from looking at the counts, right? If I just look at the people in each category, that's not always going to be the case. Here maybe I guess it sort of is, but again, keep in mind that we want to look at sort of percentages within each group to answer this type of a question. So that's very good. Did I see a question? You okay?
Yeah, I just forget, what was the original
Oh, yeah. So what is the original setting here? Okay, so I guess accidental means that they were caused by dropped weight or improper equipment use. So these are all involving weightlifting. So hopefully it's not self-inflicted, but so non-accidental would be, I guess, any other type of injury. Yeah. And yeah, good point. It is very important to keep in mind the sort of the context that we're in here. But the main point being that when you see that type of question, that directs you towards the distribution of ages for accidental injuries and then also for non-accidental injuries. And we're kind of thinking about just one subgroup of the table and then making a distribution for that sub-variable. Yeah.
For the beginning, could you just do like marginal and do like on the say 8 to 13 do like 295 out of 397 and then just like find the percent of each.
So yes. So could you use the total over here as your category? Yeah, definitely. So that would be the conditional distribution of accident type for the youngest age group. So it's asking for a different conditional distribution, but that would help you answer the question in a different way, maybe. Yeah. So again, that's maybe a better way to answer the question, right? But the question, as it's written in the textbook, is asking us for this other conditional distribution. All right. 4 more minutes. You guys want to do one more example, or do you want to go? What was that? All right. Well, I'll let you guys get out of here. We've sat here enough. Thank you so much for being here, you guys. Have a good rest of the day, and we'll see you on Friday.